Okay, Miss Weimer here again. Another explanation of another transforming trig graph problem. This one we're doing because the x-axis is going to look a little different than most of the problems that we've worked on. But we have the equation here of y equals -2 sine times x plus pi over 4 minus 4. If we're following the steps, the first things we want to do is just identify our parameters that we're working with, a, h, and k values. Oops. And then we also want to recognize that this is a sine graph, not a cosine graph. Okay, so if we're looking for our a value, we see it here with -2. Now that -2 means that it's stretched by 2 and it's also flipped or reflected over the x-axis. Our h value is in parentheses, x plus pi over 4. If we're adding, it means we're actually going the opposite direction, so we're going left pi over 4. And our k value we see here is -4. That means the whole graph is shifting down 4, which means -4 is our new midline. And again, this is a sine graph. So continuing to follow the steps, we use this k value first to determine our midline. If the middle of the graph is at -4 and it's only going up 2, means the entire graph is going to happen under the x-axis. So -4 is going to be our midline. I'm going to mark that. And the next step then is to use the amplitude or the a value to determine the maximum and minimum values for our graph. So if the stretch is 2, that means our graph is going to go up 2, -5, sorry, whoa. If I could count backwards, -3, -2, and it's going to go down 2, which is where we get -5 and -6. So if we mark our maximum, it's going to happen here at -2. The graph will go no higher than that. The graph will go no lower than -6. So the entire graph is going to happen between those three lines. We have our max, our midline, and our minimum. Okay, using the h value, determine the x-axis. So in a normal sine graph, we know that we're going to mark it pi over 2, pi, 3 pi over 2, and 2 pi. And this h shift has a shift of pi over 4. Since pi over 4 is half of pi over 2, then we're also going to have to go in and mark these halfway points as well. And so the first one is going to be pi over 4. And that means we're counting by pi over 4. So if we count this first one as 1 pi over 4, we already have pi over 2, which is 2 pi over 4 reduced. After 2 pi over 4, we would have 3 pi over 4. 4 pi over 4 is the same as pi. After 4 pi, we'd have 5 pi over 4. 6 pi over 4 is the same as 3 pi over 2. Then we'd have 7 pi over 4. That is a 7. And then 8 pi over 4 is the same as 2 pi. And since we know that the whole graph is shifting left, we're going to go back 1 point. Ooh, we almost didn't have enough room here, to -pi over 4. Okay, so that's what our x-axis is going to look like. Now we're going to mark in our values. So if we were doing the basic parent sine graph, we know we'd normally start at 0, but our graph has been shifted down 4. And it's also been shifted to the left. So the normal midline points would be at 0, pi, and 2 pi. But since we have to shift everything left pi over 4, we're going to have a point at -pi over 4 as our start. Instead of pi, when we shift it back, it's going to be positive 3 pi over 4. I'm going to do those actual points in purple. And then when we shift 2 pi over 4 back pi over 4, we have a point at 7 pi over 4. So those are our midline points, and then we know that the highs and lows are between them. Again, in a normal sine graph, we would go up first, but since we're flipping this, we're going to go down first. So the middle value between our first 2 points is going to be a low point, and normally it would be at pi over 2, but it's being shifted back pi over 4. So it's going to be here at pi over 4. And then between our last 2 points, we would have a high point right in the middle of those, or you could think about it as normally it would be at 3 pi over 2, shifted back pi over 4, puts it at 5 pi over 4. And then we just draw in our points. So we have our 5 key points. The goal would be to hit the actual points, but as long as you have them marked, you should be okay. And then remember that the graph is continuous, or it repeats, it's cyclic. So we have arrows here and an arrow here, even though I'm running out of room. This is a pretty foundational skill for Algebra 2. It's definitely needed if you're going on to any classes past Algebra 2, Algebra 3, or Pre-Calc. And so if you have questions on this process, make sure to reach out to your teacher and ask. We're here to help.